All right. Hey, everybody. Welcome to Data Engineers Lunch number 8. This is the second one for the year. We had one last week where we discussed relational databases. This week, we're going to discuss relational databases part 2. There's always more to learn. Akwi, thanks for helping produce this. We're always looking for help in making this run. These days it's all on Zoom, so it's pretty easy. You don't have to go anywhere and help put up the drinks and wait for the pizza. We are part of a much bigger community of practitioners. Have people from all different backgrounds come and speak, and we're always looking for people from different backgrounds to come and speak and be represented if they're underrepresented. Data Community DC is a part of, we're a part of Data Community DC. And Data Community DC is a part of a larger tech community. So there's intersections here with other technologies, not just data related. For example, Full Stack DC, they cover everything from the front end all the way to the back end. We have, what we cover here are basically the nitty gritty details of how to deal with data. For the purpose of either, cleaning it so that people down the line can use it to visualize it, to explore it, to do, to apply machine learning or data science processes to it. All different types of processing around data, whether it's ETL, ELT, event processing. Hopefully we'll get to cover all of that. Let's see, are there any new team members to the group here? Looks like most people have been here before. We had like 4 new people last week. It was kind of fun. Let's see, group rules. If you have a question, just ask it. And on the chat or verbally, you can unmute yourself. We had Anant. We help our clients with data platforms. We do this stuff for a living pretty much. DataStax helps us out by getting the word out and getting pizza and beer when I think, yeah, they paid for beer once, but definitely they pay for soda. GW gives us great location. I saw as I was walking around the other day that students are slowly coming back. So I think the campus is going to be open. So maybe we wait until the vaccine goes out and try to do an in-person event. We have local sponsors in Chicago and DC for this group. And of course, we have our institutional organizational sponsors that get exposure by donating to a nonprofit. So if you know anybody that wants to be pimped out on the interwebs now, that can help a nonprofit like Data Community DC, that'd be great. All right, any announcements? People looking for work, people that have jobs that are looking to hire people. We actually are always looking to hire people, but right now we're kind of backlogged with work, and on our partners like Confluent and DataStax are backlogged with work. So if you are keen on data ops with Spark, or data engineering, with Spark or Kafka, reach out, and Cassandra, and reach out to us. You can just direct message me. Yeah, actually, Will, I was gonna mention that there's a couple of events coming up. So there's a data visualization monthly event on the 14th. There's a statistical seminars on the 25th. I don't understand half the stuff on the statistical seminars topic, so I just don't even try to explain it. they're so above me, I have no idea what they're talking about sometimes. And then Data Science DC has a very interesting, but they're going to have, I think, Tim Berglund, who is like a rock star in the Kafka world, and maybe the CEO of Confluent, give a talk on using Kafka for interactive or real-time user interfaces, user analytics. If you could do me a favor, Akwi, mute everybody except for me. There's some background noise. Appreciate that. All right. So yeah, as I mentioned earlier, we're going to talk about relational databases today. This has been my kind of career working with data for a really, really, really long time, and I'm sure a lot of folks here have also worked with relational databases for a long time. Before getting into NoSQL world, but technology as such, as we get older, new people start to get into technology, and they've only really worked with non-relational technologies. So hopefully this is a refresher for folks who've been working with relational databases, and an introduction for people who have not used relational databases, and to basically, think about the tooling. Last week, and this should be up on YouTube, last week we talked about the history of relational databases, right? It's like a long history, 30, 40 years. What are the popular databases that are out there? File or in-memory relational databases, the open source databases that we're going to cover today, and then obviously the commercial ones that the big companies use. Not that big companies don't use open source, but normally you kind of have to have a big bank account to use Oracle. SQL Server being a little bit more affordable, and Sybase, it's kind of a older database. It's still around, and a lot of people still use it because they don't need to fix what's not broken, essentially. So in fact, what I'm going to do is I can just copy this into today's discussion, and we can go from there. So from and I'll talk a little bit about the in-memory databases as well. So, oops, sorry about that. This tool, by the way, Workflowy, I'm pretty sure it runs on a non-relational database. I'm pretty sure, because it has infinite nesting. I mean, I guess you could definitely do it with a parent-child relationship, but it's really sweet. So I don't want to spend too much time on file or in-memory databases that are relational. Frankly, because if you're doing any heavy data processing, data engineering, you probably are not using this. Although just last week in a task that I was working on for a client, we did discuss using SQLite for storing the state for a tool that we're creating that needs to run by itself. Like it has to, it's a Python application, but it needs to run by itself, and it's used in a disaster recovery scenario, rather business continuity. So it's, making sure that there's no disaster. It's just to help manage a highly available system. And the goal of the job was to, if you guys have ever used, Hive or Spark SQL, right? There's a metastore that stores information about the tables and how they are stored inside, or what is backing that. And basically, regardless of which Hive implementation you use, at some point, if you want to switch it from one location to another, you have to describe that table, you have to get the location, then you have to do an alter statement. Well, there's a lot of information beyond just the table name and the location. There's the schema of that particular table. And so we were thinking about, taking the output of the describe extended statement and saving it in a CSV versus SQLite. I actually ended up using CSV because CSV is easy. I can just open up a CSV file and look at it. But and what I really am getting at is that you can use CSV to have different tables basically as CSV files, and you can do operations on it like an in-memory database, especially if you're using a framework like Python. You can read the data from CSV into a data frame, you can do operations on it, and then you can save it back, right? So actually that's about how these in-memory or file databases work. They're just a place to store data, and the engine, the driver itself, has the relational engine, right? The file doesn't have anything. It's just whatever you're using to access that data has the engine for relational joins and whatnot. So SQLite, it's very popular. Lots of applications. If you look at the, when it bootstrapped itself, bootstraps itself. It may be storing some information in SQLite to run itself, right, before it connects to another persistent system. I don't know if anybody writes tools that bootstrap on a CSV file. I doubt that, but that's why I would say if you're not familiar with SQLite, become familiar with it, because it could save you in a bind. Other relational databases that are common. So Microsoft Access is probably one of the most popular relational databases that people use. It's not a multi-user concurrent database. I mean, you can write apps that run on top of it, but it has to manage its own connection pools. And for the longest time, when I was getting into web development, we would write ASP Classic applications or even PHP applications that would talk to a Microsoft Access database. It's like a .mdb file, and you can just move the whole file, right? All the tables and everything, all the views, it even has support for forms. It was all sitting in this one file. That's why it's attractive to customers. It's like Excel, but with forms. And so people would store a bunch of data in there, customer information, financial information. Why? Because you can do basic analytics on it, right? You can do averages and sums, and you can do joins inside Access. You can even have views inside Access. So that's why Access was and is very popular today. When a database actually needs to have more concurrent users, more concurrent connections, that's when people will start to use something called MSDE or SQL Server Express, which stores its files in a .mdf file, which is basically the same format that SQL Server uses, but it's an in-memory engine, basically. It just brings up the data and it does it all in memory. You got to have a pretty good, Windows server to do it. But why would we use this in the world of data engineering? Again, similar involvement that SQLite has with tools. You can have, let's say, if you're building a system that's built on top of C#, and you're just used to the SQL Server world and you're used to Microsoft, you can just say, make an MSD instance, store my information here. And mind you, like, you're not going to be moving data through this. I mean, you could potentially be given an Access file, you could be given a SQLite file as an ingest, but I would not recommend storing, massive amounts of data in here. Maybe it's a transitional space for information. And I'm just saying that just the world that I work in, it's all big data. It's all big data stuff, fast data around big data. So these type of things really just have one place for me. Now, other people may use it for different use cases. Anybody else have any comments on these in-memory databases or in-memory files? Or, and I shouldn't say in-memory, because there's something called SAP HANA, which is an in-memory database. So just really say file-based relational storage, but in-memory query. I'm curious if there's anybody else who's heard of anything else other than these. Okay. I should mention Sybase actually has something called SQL Anywhere, which works on embedded systems and can work on your iPhone or Android. And it may have a way to kind of, I don't know if it's actually architecturally similar to this, but I know people use it for like point of sale systems.
I've heard some people try and do horrific things with using YAML files as like data persistence, but that sounds unwise.
Yeah. I want to say that that it's, well, technically, yeah, you're right. You could have data stored in a YAML file. You can load it into data frames, and you can do operations on it. You can store it back into a YAML file. So sure, I will put that here as not recommend. Yeah, for sure. People do weird things. On the open source front, there are many more open source databases out there, like tons and tons and tons of open source databases out there. There's a really good site, I think it's called DB Engines, which if you're not familiar with, bookmark this site. And you can basically, let's see, if we go to relational databases and get the ranking, right? Here are the most popular users. And it just comes from where you work. If you work in a startup, you'd be like, why should I ever use Oracle? You know, or like if you're working in a Fortune 50, they would say, well, why should I ever use MySQL? But Oracle, MySQL, Oracle, I think MySQL is owned by Oracle now, at least the last time I checked. But if you want to do open source, then let's see if I can just filter by open source. I'm not able, I don't think I could. Right, so this is kind of the trends, right? Commercial licenses are decreasing, open source licenses are increasing in terms of just and general databases. But you know, back to relational databases, Oracle and Microsoft are kind of the most popular. IBM DB2 coming in there. Open source databases here: MySQL, PostgreSQL. Hey, look at that, SQLite. It went up a point. Microsoft Access is still around, as you can see. MariaDB is a fork of MySQL. I think the person that actually worked on MySQL is basically now maintaining MariaDB after MySQL was acquired by Oracle. Yeah, go ahead, Will.
Oh, yeah, I was just going to say that the original creator of MySQL forked MySQL into MariaDB, I believe, on the day that Oracle acquired MySQL.
Yep. Teradata, which is actually, you know, there was a part of Teradata that did Presto that spun off into Starburst. But anyways, that's just trivia. Teradata is used for data warehouses. Microsoft Azure SQL Database is basically their cloud version of SQL Server. Hive, interesting, they put it under DBMS, but basically Hive is a way to do SQL queries on files. And let's see some open source. This is open source. Let's see, FileMaker. I don't know why I didn't mention that. Yeah, FileMaker is actually pretty popular in the Mac world. People that have Macs for their office desktops and laptops. Firebird, I believe, is open source. Informix is not. Commercial, open source. Spark SQL, we talked a little bit about. Snowflake is commercial, open source. So anyways, this is the whole gamut of relational databases. And if I go down all the way to the bottom, there's like rando ones like DuckDB, which has a rank of 0.1, or like it's ranked 132. But the fact that there's a database called DuckDB makes me curious, like, what is this thing? Why would somebody even have a database called DuckDB? Let's see. Embedded SQL OLAP database management system, written in C++, you know? So there you go. If you're bored with any of this other stuff that people actually use, you can go to DuckDB. In terms of like the common stack, if you had used you know, Linux, Apache, MySQL, PHP, and then it became also Python, and it was for a while, it was even Perl. People did Perl. This stack, commonly known as LAMP stack, is what made MySQL popular. It was the combination of Apache, not just Apache project, I'm talking about HTTPD. That's what Apache was. Originally, Apache was just the server, the web server. And then the way that people would deploy LAMP was they would basically compile Apache with the plugin for MySQL with PHP, and the PHP was compiled with MySQL support, and it was a whole like song and dance. And that's how I learned how to use Make like 20 years ago. But this is the reason why MySQL became very popular, is because it became a competing technology for making apps on the web to ASP, Microsoft ASP Classic, and Microsoft Access. and you could have a database up and running. You could have a multi-user database, multi-database database, and the hosting companies would just bring up these big MySQL servers and give any user a MySQL database. If you want to play with MySQL, the tool that everybody should know how to use is called PHPMyAdmin. And if you've never used PHPMyAdmin, highly recommend it. But this is the reason why MySQL became so popular, because you would have a MySQL database. Even if you didn't have an app already written, you could use PHPMyAdmin to create your tables via web-based interface. And then you could add data and you could do queries on the data all inside this web-based interface. And basically giving people that wanted the power of Microsoft Access, small databases, it gave that power. And as it grew, people started to really use MySQL more and more. Open source technologies didn't start from big companies traditionally. It didn't start from big companies and become open. They were grassroots projects, like Linux was a grassroots project, PHP was a grassroots project. Tinkerers would play with this stuff, and it became wildly popular in the .com world, in the .com era. And this is why MySQL is everywhere, right? So MySQL, there's a variant called MariaDB, as Will mentioned. It got forked from MySQL the day that MySQL got acquired by Oracle. GaleraDB is basically MariaDB, but in a masterless architecture, meaning you can have multiple instances of Maria talking to each other, where you can do reads and writes from any of them. And it's all MySQL, right? It's all the standard select, insert, update, delete that you would do, but you can do it at scale. And these are instances that you would get on Amazon. RDS it stands for Relational Database Service. It's basically database as a service. You say, I want a database, I want it to be this capacity, and I want it to be backed up about 50 times, but it's expensive. But this type of stuff is getting popular in the enterprise, because who wants to run a Linux machine, install MySQL, tune it, manage it, deal with it, if you can just pay AWS some, $5 a minute or whatever it is to get a rock solid multi-region replication for your information. The difference between MySQL RDS and AuroraDB is that AuroraDB is basically like Galera. It does a masterless read-write. And then TIDB is a new SQL database that uses the MySQL compliant SQL. Technically, all of these things should be using ANSI SQL, technically. And a lot of the create statements for a table or an alter statement for a table, they look very similar. Or a lot of the selects and inserts and updates, they basically look the same. But there's slight small differences. So you may be able to get by taking an SQL export of a MySQL database and importing it into Postgres. You may get really, really lucky, but I doubt it. You may be actually fine if it's an insert statement, because insert statements don't change that much in terms of syntax, or delete statements or update statements. They probably don't change that much. But the schema creation, the DDL, is slightly different, right? MySQL, my final word on MySQL is it's like a programming language like Python. You never know when you're going to need it, but when you do, you might as well be comfortable with using some of the command line tools to get into MySQL, create a user, connect to MySQL to get data in and get data out. MySQL is a server. It runs. It also, I shouldn't say final word. The other thing about MySQL is that there's different data storage engines, okay? And you're probably never going to deal with this if you don't become an expert on MySQL, but there is something called MyISAM, and then there's something called InnoDB, and they keep adding, so MySQL database storage engines, what do they have these days? Let's see, InnoDB, MyISAM, Black Hole, oh, dev/no, okay, I mean, I don't really care about that one. and then performance schema. But yeah, I mean, normally you're using InnoDB or you're using MySM. Okay, but take a look at this, right? You can even have CSV as your storage engine. That's new. I've never done that on MySQL, but worth learning. My only experience with these type of engines is that one of them stores data in different files and for each table, whereas one stores data for a whole database in one file. And there's pros and cons to that, but essentially when you get down to it, databases are going to be choked on memory, CPU, but eventually disk. So if you have a bunch of CPUs and you have a bunch of memory and you want to get really, really fast, you want to end up using the database engine that allows you to have multiple files, basically a different file per table for it to go fast. And somebody can kind of tell me which one that is, because I am completely, this is like such a long time ago that I learned this. I don't even know. Let's see, files. Here, we'll ask the Grand Oracle Google, ISM versus InnoDB. There you go. Does anybody know which one has the multiple files for InnoDB versus MySM? Here we go. Oh, this is a conversion issue. Oh, here we go. InnoDB has row level locking. MySM only has full table level locking. InnoDB has what's called referential integrity, which involves foreign keys. That's important. Supports transactions where you can commit and roll back. InnoDB is more reliable because it is transactional. So, you know, honestly, I guess I've only used InnoDB because I've never really had an issue with this. Here's PHP@MyAdmin. That's what I was kind of telling you. It's a web-based interface. I'm going to save that in here, and we can put this on the blog later on. Cool. Going on to Postgres. So Postgres, as I had mentioned, is kind of in the same lineage as some of the first relational databases. And Postgres, at least from my understanding, I started using and playing with it because it had better data types, more data types. It also initially, before InnoDB came into MySQL, I had always heard that Postgres had transaction support. But in terms of the data types, it supports XML, it supports JSON. Some cool things about Postgres is you can even run a Mongo compliant database on top of Postgres, meaning using their JSON engine. It's kind of interesting. And it has, and maybe MySQL is caught up, but Postgres also supports federation. You can connect other Postgres databases into your Postgres database and query it with your tables. And I think I saw that on MySQL 8 somewhere. Postgres's organization of its data is slightly different. So it's not just a database and you have tables. There's a concept of like a schema, and then there's a database, and then there's also tables. I believe Postgres also has a concept of stored procedures, where in the stored procedure, similar to in SQL Server, you can essentially have inputs and outputs, right, coming in, and you can do SQL inside your procedure and execute SQL operations. I don't think MySQL has stored procedures. It's been such a long time. Oh, they caught up. So stored procedures in general are, normally you can do anything you can do in any programming language. But it's basically if then else type things. You can do your SQL operations. You can do loops, some basic error handling. So why would you use a stored procedure in MySQL or Postgres? Well, imagine that you're doing an SQL operation with Python, where you do a select star from do some basic SQL data manipulation, and then you insert it back into another table. Well, if you make a stored procedure, you would just say, call this procedure. And if it doesn't make any difference to you whether that SQL is running called by a Python program or called by the stored procedure, that's one. The other is that when you write a stored procedure, it starts to optimize the paths that it's basically getting the data, depending on which engine you're using. And the stored procedure is kind of compiled internally. And the stored procedure will run much faster the next time you do it. It doesn't escape you from like index design and data model design that would potentially choke a stored procedure, right? If you have a bad data model and if you don't have indexes where you need indexes, your stored procedure is going to choke the same way that if it would choke if you called it from a programming language. But stored procedure it's kind of again, in the relational world, we used it a lot. It allows you to contain in one database, dump or backup or whatever, the data and some of your data access logic combined with some business logic, right? So if you're thinking about rolling out software to do a change in your business logic, if you had that logic in your database, you would just update that one procedure and then everybody was able to access that same procedure. So this is why stored procedures were and are useful, is that you can wrap things in a stored procedure and then give access to people. Database administrators, for common tasks that they were doing for folks, they would write a stored procedure and then give access to the stored procedure so that the user could just run a stored procedure. These days with microservices architecture, you may not necessarily ever use a stored procedure because stored procedure is an anti-pattern. It's inside the monolithic database, and if the database goes down, the stored procedure is basically not accessible. So you probably be doing the same operations outside. And in the world of monolithic databases versus microservices, a stored procedure is also another anti-pattern in that a lot of folks want each microservice to be backed by a different table or a different database that may not necessarily sit in the same world. Now, getting into data analytics platform architecture, the whole microservices architecture is an anti-pattern for data and analytics, meaning that you have to store your data everywhere, and then you have to bring it together to do stuff with it. So that's kind of like a debate that I have with folks, is that you got to find a balance, right? So I would say that using a monolithic database like MySQL or some distributed variant of it, there's still a lot of value in it. And the way I see it play out these days is that folks will migrate from Oracle to Postgres. And they will, or they will have started off with MySQL somewhere and they'll go to Aurora DB or AWS managed MySQL or Azure managed MySQL because they don't want to manage it. But this is a common trend. Oracle to Postgres or SQL Server to Postgres. And the reason people move from these commercial databases to open source is twofold. Number one, there's a lesser license fee, meaning you may still pay somebody to support you, but it'll be lesser than these license fees. But the other is that it's, you're not necessarily locked in. You can use MySQL, you can use one MySQL variant today, you can go to another MySQL variant tomorrow, versus like there's only one Oracle, there's only one SQL Server. But there's another shift that's happening, which is people going from self-managed databases. I'm having trouble. Self-managed databases to cloud-managed databases. And the cloud-managed databases are, for the most part, are like, they're the same engine, right? So you can go to Ivan or AWS or Azure. Google has different databases. They don't have the same ones. But when you go to a cloud-managed database, you may still do local engineering on your desktop or your Docker container using these open source databases, but because it's exactly the same technology that these people are offering, you can just connect to it and use it the same way. What do you get out of a cloud managed database? You don't have to worry about it when it goes down. The system should bring it back up if something happens, or it has multiple backups of the data so that when a node goes down, it automatically detects it, brings up another machine, attaches the drive, and everything is hunky-dory. So skill-wise, if you're good on MySQL and Postgres, you can pretty much use 80% of the world's cloud managed databases. For example, Google's Spanner database is Postgres compliant. If you know Postgres, you can use the same. It has the same exact interface to it. Other cloud managed databases that are kind of MySQL or Postgres oriented, I believe there's something called Yugabyte Cloud, or whatever they call it, but they have a Postgres compliant database. And then Cockroach DB Cloud also has Postgres compliant. I don't know if there is a TIDB variant that you can get from the cloud. To round it out, commercial databases, as I mentioned, why do people use them? It's like that old saying, you don't get fired for hiring IBM. You don't get fired for buying an IBM. It's the same way. Certain brands they become so ingrained in people's management structures that they just keep renewing the licenses. And there's nothing wrong with it. I mean, Oracle, if you remember from the last week, is one of the first implementations of relational databases. Relational database was a paper, and Ellison took it and made it the first implementation. I think it was a government contract to make it into a database. So of course, 40 years of engineering, millions of dollars in engineering, there's a reason Oracle's still king in terms of the database world. I mean, we saw on that ranking, right? Where did it go? I mean, it's still king, right? It's like, got MySQL still got a little ways to get there. Who should learn to use Oracle? Anybody that's serious about working in a big company. It's not going to go away. In fact, Amazon even has something called Amazon RDS for Oracle. They also have Amazon RDS for SQL Server. So some companies may say, you know what, we'll pay the license fee. We just don't want to pay for the labor to keep the servers up and running. So we're going to just pay Amazon to do it. But Oracle is more than just a database. Oracle is an ecosystem of tools and platforms that run on top of Oracle. There's like Oracle CRM, there's Oracle HR, because Oracle kept buying companies that made software that ran on top of Oracle, right? So anything that ran on Oracle that was an appealing acquisition, Oracle would just buy it. So Oracle is not just a database, it's everything around it. And that's why it's still relevant in many companies, because they've not just bought into a database, they've bought into an ecosystem of applications that help them run their companies. SQL Server, on the other hand, is not in the same boat. They don't have the same clamp on people's balls like sorry about that, like Oracle does. But as you can see, it's still up there. It's very popular. And it's because I saw the popularity rise for SQL Server. SQL Server 6.5 was basically, they had bought Sybase and they put their logo on it, and that was SQL Server 6 and 6.5. And then SQL Server 7 became useful for people that were doing Microsoft Access and ASP Classic development because it would hit a limit. Right? You can only put so many transactions on a Microsoft Access database. So at that time, before SQL Server Database Engine, SQL Server 7 was the next thing to do. And then came SQL Server 2000 and SQL Server 2005 and SQL Server 2012. And each time SQL Server kept dropping their mic and saying, look at us now, because it was a $5,000 per server cost versus basically what can you pay us type of cost. And so, when I was running a hosting company, we paid that $5,000 and we made that money back because people would pay $25 a month for one SQL Server database. And that was cheap, right? Because SQL Server gave people an ecosystem around Microsoft, sorry, it was part of the Microsoft ecosystem. It also eventually started to have CLR data types, where you could have a C# object as the storage, as the data type for your column. Right? You could have a custom object for your data type. You could also have compiled code. You could have C# stored procedures, .NET or any .NET stored procedure that could go in there. And to this day, it keeps impressing me. Back in 2005, it had XML and XSLT, XML and XSD. So you could have a kind of a hybrid, structured and non-structured data store inside SQL Server, where people are trying to achieve that now with Postgres. SQL Server actually made it pretty easy. And you could write an XPath query and get back data back. Oracle had it for a longest time. Oracle had been, ahead, and still is ahead of a lot of folks in that it has the bleeding edge of a lot of relational database technologies, but SQL Server was affordable. One of the reasons I think SQL Server is still popular is that they have a really good SQL Server management studio. And I don't know what it's called now, but it allows you to connect to different databases, and it's free, right? It allows you to connect to different databases. You can go in there and say, run an import job. You can import data really easily. You can export data really easily. The names of the tools have changed a little bit, but you can do a lot in this management studio. And when you compare it with Oracle, like you have to do the command line, or you have to get a tool like I think Oracle now owns it, called Toad. And it's a different world when you can just open up one program and just do everything you need to. So people are curious, why do people use this stuff? Well, it's because if somebody has a job, and their job is to, as a CIO, to help run a multi-billion-dollar company, and if they have to run it, they have to rely on other people. And if there's a person that has a job that likes using a tool, doesn't want to give it up, well, guess what? That's the right reason for them to keep it, because they're not going to find a replacement for that person with 15 years of not only the technology experience, but also domain experience in that company. So tools really do make choices easy for companies, whereas just as an open source developer or a startup entrepreneur or a startup technologist, you use whatever you want because you like using it. That's the same reason why really large companies, they keep using these other tools that seemingly don't make sense. Why should I pay money for this? Well, what people do is they spend money in some way or form, right? If you're using open source, okay, you got to pay somebody to run the systems, or you have to pay like a person, or you have to pay somebody like Amazon to do it, right? So at this point, if you can just use a cloud managed database and you compare the cost of an Azure managed database versus a Google managed database versus an Amazon managed database, like you probably don't care what the technology is. You just want to ask the developer, like, what do you like to use? But at the same time, some of these Oracle databases, they're inside a corporate data center with terabytes of data. And there's little or no reason to move from it unless there's a strategic direction that, hey, we want to reduce our millions of dollars of license fees for Oracle. And I don't know if that's going to change. I don't know if Oracle's going to reinvent themselves and make it more appealing or not. But then again, Rolls-Royce never had to make like a poor person's car, right? Because that's basically what it is. Oracle is like the Rolls-Royce of databases. SQL Server is like the Lexus. They don't have to make a cheap version of their database because people are willing to pay for it. I'm about out of stuff to talk about these databases. Did anybody want to add to the conversation? Did anybody have any questions about these databases or something else? Let's see. Interesting. SQL client tools. Wasn't JetBrains being reported as the initial hack tool vendor? And oh, wow. I didn't know that, David. Could you expand on that?
Yeah. I thought that JetBrains was I think it was probably an ARS or some other security blog saying that JetBrains was the likely first vendor to get hacked, but certainly don't repeat that without verifying it. It's off the top of my head. I saw that it was JetBrains, and I was like, I know JetBrains. What is JetBrains? And then I was looking at client tools just now and said JetBrains, SQL client tool. So don't trust my fuzzy brain, but I believe that's so.
Well, you know what?
I think it's SOLR, or is it? Oh no, I'm sorry.
Oh wow, okay. JetBrains denies being involved in SolarWinds hack.
Oh yeah, then I saw that it was a Czech company, which makes it hard to
Yeah.
use at my client.
Yeah,
What
interesting.
they do.
Wow.
That's a bit of an aside, but I was also looking for SQL clients because I forgot which is the one I was using on my Mac OS, and I updated my Mac and I can't remember what it was.
Yeah, actually, that's a good. Actually, I can bring that up as a topic right now. Like, there is one called dbeaver. Dbeaver, yeah, which connects to like everything. There's an open source version of it, and there's a commercial version of it too. But like, it can connect to Presto. It can connect to even I think Cassandra. It can connect to Hive. Put this in here. Yeah, dbeaver works with a lot of different databases. This is one, and then I think there was called Database Visualizer. Oh, I think it's called Netcat. No. There's one more, which is, it'll come to me because it usually ranks as one of the more common ones. Navicat, that's what I meant. Navicat is actually really good too. I don't know if it does. Yeah, it does more than MySQL. It does Maria, it does Postgres, and it does MySQL. Oh, that's cool. They added some cool data modeling tools. Oh yeah, that's right. So another reason why people love using SQL Server is that you could visually design your tables, right, in like a pseudo ERD diagram. Made it really easy. I use it all the time. Let's see. And then there is one more. Yeah, DB Visualizer. I don't know if it's like a data. I've used it to like document a database, and it's pretty good. Like is this JetBrains? No, because I was like, for a second, I was like, it looks like a JetBrains website. There we go, DBViz. Let's see where to go. Like, when you mean like a tool, David, are you talking about like stuff like this, or what kind of like use case are you talking about for a database tool?
Oh, exactly this. Just something to connect a SQL database and add tables, add users, all the things.
Yeah. Yeah, I mean, from a basic SQL tool, I think you can't go wrong with dbeaver. In fact, like at some big clients, I've turned them onto it and they've started to buy licenses for it because it's not that expensive, but like you don't need to buy it. It's just the only reason you would buy it is to get like access to certain, Enterprise Edition has NoSQL and big data database support, basically. Visual Query Builder, query history, but I mean, if you're not talking to Mongo, Couchbase, Cassandra, right, basically, then you don't need the Enterprise Edition. This is a big part of my work. Technically, I'm like, yeah, you should probably buy it. Cool. Yeah, and like everybody copies from basically Toad and Microsoft SQL Server Management Studio. They all end up looking like that. What was the JetBrains tool for SQL Server? I think it's built, sorry, for SQL, it's built into everything, right?
That was the thread vector, but I'm not terribly familiar with it.
Yeah, DataGrid. Yeah, they separated it out. This is it. Yeah, very cool. I love JetBrains. I use IntelliJ all the time for Scala development. And before that, Like they had something called PHP Storm, I think. Yeah, they've got really amazing. I didn't know they were a Czech company. That's kind of interesting.
I didn't either. When they show up on some of my clients, I don't know if anyone actually got the authorization you need for that kind of thing, but I know it's on their networks.
Wow. No, I should make some of my clients aware of that because, yeah, that's all. I just need to make people aware of it. Cool. Very cool. All right, folks, we're about out of time today. We talked about relational databases, the different variants, going deeper from our conversation last week about relational databases and some tools. I'm going to ping Will to see if he can talk about Airflow 2.0 next week, but there's a bunch of stuff in the pipeline back here. By the way, Mike, did you want to give a quick plug? We did plug statistical seminars earlier. Did you want to give?
Thank you. Appreciate it.
Yeah, go ahead and announce your next meetup. I'll bring up the website. Just explain it. Yeah.
Oh, thanks. Yeah. Well, right now I'm planning to do some intro to R, so that's coming up soon. But I'm still like putting the slides together. But for right now, I'm just cross promoting an event with the Washington Statistical Society on January 25th. That's coming up. Her name is Martha, and she's going to be presenting some information about database and SAS and some analytics. And also, if anyone's interested in volunteering, Data Community DC is more than welcoming volunteers. If you're looking to volunteer to help support a meetup or looking to use your marketing skills to manage social media tools that DC2 uses, feel free to let myself know.
Yep. Thanks, Mike. Appreciate that.
Yeah.
Yeah, it's a great group of folks that I was on the organizer group board. I guess technically I am because I'm an organizer, but there's a lot of really amazing people that are in the community that if you've never done this opportunity, like working as a volunteer in something like Data Community DC, it really exposes you to the whole world of professionals around data. And Data Community DC is it, right? In the DC area, like I don't know what's the number now, 23,000 or something crazy, and then number of professionals across all the groups.
There's a lot.
Yeah, there's a lot. I think the data science group is the biggest one. And just that alone, I believe, is like 20,000. Let's see what we got here. Okay, no, overlapping, it's at 13,000, but point is, if you get involved and you're building your career, or if you already have established career, it's a great way to just get exposure.
Great networking, exposure and different things. You also gain some experience too.
Yep, definitely. Yeah, you never know who you're going to meet there. Awesome. Well, thanks, Mike. Appreciate that. Yeah, guys, we're at the top of the hour. Good seeing you. We'll be back next time, next week, same time, same place, Mondays at noon, Data Engineering's lunch. All right, take care, guys.
Hey, Raul, are you